My trusty Sony 8-inch Trinitron bench monitor has developed a problem. It won't turn on. Let's see what's going wrong with this one here in today's episode of Tech Talk. Okay, got the TV down on the bench. You'll notice that there's a bunch of tape around here. That's because when I got this TV many years ago, it was given to me. Little old lady that bought the thing. She probably paid $600 or $700 for this thing. These little portable AC/DC sets were worth a small fortune because this one will run. As you can see, this one can run off of 12 volts DC as well. So these small portable AC/DC TVs were quite expensive. And what had happened with this one was that it got dropped. And she broke the case and she broke the circuit board inside. And when it came into the shop, she was told, yes, we can repair the board. We can get a new case for it. She was told how much the cabinet was cost. The cabinet itself was like $100 for the cabinet. And we could repair the board, but the boss went on and stressed, we can't guarantee this thing. We can't guarantee it's going to last you any length of time. It might last you a week, it might last you a year, it might last you 20 years, but we cannot put a guarantee on how long this thing's going to last because it's been dropped. And at that point she walked away from it and bought a new one and said throw it out. So I grabbed the TV, fixed the circuit board, and stuck the cabinet together with tape. And I've had it ever since in my shop here. Had it actually in the shop at work. And then when I left, I took it with me. So I got to cut all this tape away so I can get into this thing and see why it's not turning on. These two screws actually were the only two screws that actually still went into anything, because what happened in the cabinet is when it got dropped. See, that was our concern at the shop, was that we could fix it and not know the picture tube was damaged because it fell. But cover comes off. Here is a little Sony Trinitron picture tube. You can unplug that antenna connector. I don't even know why I bother even connecting that thing. There's no analog broadcasts that I can pick up anymore on this thing. It can only pick up closed circuit stuff that I input. And here's the unit. We have a power supply over here. We have our signal board over on this side. And this one's our AV input and our deflection board. And our little Sony Trinitron tube. Kinda like that. And on top of here, these little magnets were stuck on. That is how they corrected the geometry on a Sony tube, in addition to the convergence adjustments on the back. Well, not every tube was perfect. So what you would do is you'd put a piece of double-sided tape on and you stick a little magnet on the corner of the tube to tweak the beam to correct your purity or correct convergence that was off a bit. So the fact that this TV has no power whatsoever means I'm going to concentrate on the power supply. So let me get the power supply out of this thing, and then we'll do some voltage measurements and see if we're getting power. First, an inspection of the fuses. They look okay to me. I don't see any breaks, but we'll check with the meter and make sure that we don't have a failure of one of the fuses. That would make this a real simple fix if it was a blown fuse, wouldn't it? So get the meter in diode test mode. Nope, that one's good. And that one's good. Therefore, our fuses are okay. Next we'll go and we'll power up the power supply and see if we have any voltage coming off it. This is an inverter, this power supply. So everything's going to be underneath here. Here's our little inverter transformer and our chopper transistor. One of these is going to be the chopper transistor, and one of these is going to be a diode. Don't know which one offhand. I'd have to pull the bottom shield off it to see. Q601. And this is the diode over here. This one. It's a double diode. That's our or full wave rectifier off of the transformer, but in this case they've got it wired as a half wave rectifier because they've got both of the anodes are wired in parallel with each other off the same winding of the transformer. So first things first, let's see if this thing's putting out any voltage. Let me get my power cord and get it plugged into the isolation transformer. So on a power supply like this, we have a hot and a cold side. We have two different grounds. We have a hot ground and we have a cold ground. If we're going to measure anything on the primary side of the transformer, which is this side here, here's our transformer here. This is our secondary side, so the diode and everything on this side of the transformer is considered cold, and anything on this side of the transformer is considered hot. So our cold ground reference is going to be the shield and all these components here, including the DC fuse, and the hot side is going to be, the hot ground is the negative here of the main filter capacitor. So we'll clip our probe on there, and we want to measure and see if we've got our raw DC. So got our probe clipped on, got our meter in DC voltage mode, and we'll turn on the power, and the first thing I'll do is I'll just measure the voltage on the main filter, and I see that I have 161 volts. Therefore I know that we have power. Now I could put my scope on here to see whether the oscillator is running, but there's an even easier way. Let's just see whether we have any DC power on the DC side. So I'll clip my meter onto the cold ground, and then I should be able to measure one of these pins here on the fuse. So turn the power back on and just see whether we have any voltage. And we do. We have 20 volts DC. This is a DC to DC converter. We're taking the 150 volts DC from the primary side. And if I measure it to hot, by the way, it'll show me 65 volts. And if I measure it to the hot ground, it'll show me about minus 65 volts because it's floating, right? But so what goes on in here is there's an oscillator that runs, which is switching that 165 volts on and off at a fast rate, and it's going through the transformer, through the diode, and down to my DC side for my 20 volt supply for the TV. So I got 20 volts on the power supply, but I have no TV function. Therefore, the problem is not in the power supply. As you can see, when I turn it off, the voltage drops off real quick. The same with the hot side. Will drop off really quick. You know, you'll hear people say, oh, these things can store power for a long period of time and bite you. Well, watch. I'll turn on the power. This is the hot side. Okay, charge up to 161 volts. So turn off the power. Watch how quick it's going to drop. It drops real quick. So people that will say, well, these capacitors can store power for a long time, that's not necessarily the case on solid state devices. If there was no load, if the oscillator was not running, then yes, that capacitor could store power for, you know, a good period of time. Usually they're going to have a bleeder resistor to bleed it down so that it won't stay charged forever if there was no load on it. But the fact that this power supply is working, the circuit is running, so it's going to drain the power out of the main filter capacitor pretty quick once you remove power, until the oscillator shuts down, and it'll drop it down to a few volts, and then it'll shut down. And then the capacitor might, you know, hold a few volts for a period of time. It's, you know, it's got 0.6 volts in it now, I guess, right? So it's not going to hold power for very long. Same with the DC side. DC side, if I turn it on, there it goes, 20 volts. Turn it off, it'll stay at 20 volts for a few seconds, and then boom. As soon as the main power supply drops, it'll drop, and its voltage is going to drop off pretty quick, just because there are loads on here. The TV, for example, is plugged into the standby circuit, and the TV is going to be drawing some power, so it's going to drop it off pretty quick. When you're working on CRT televisions, it's always a good idea also to unplug the neck of the CRT before you do any work trying to separate boards and stuff. That just reduces the chance of catching a wire and snapping off the glass here and breaking your vacuum and ruining your tube. So the fact that this chassis is broken on this thing also, I'm going to unplug the yoke plug down here in the middle so that I can actually remove the tube from the set, because I want to look. The next thing I want to check is I want to check the actual switches on the front to make sure that the actual power command from the switch is getting to the set. So I have to look at the front panel and see. It might be a bad switch is what I'm thinking. Maybe one of these switches is stuck. How these things operate is it's typically a voltage divider network, and all the switches are connected to the same bus with a different drop resistor. So if one of the switches were to get stuck or fail, it'll lock all the switches out. So the next thing I want to check on here is I want to check to make sure that we're actually getting the power command from the switch. So to do that, I'm just going to lay the TV on the front, the tube down like that. I'll swing the chassis out of the way out over here just so that it's not going to break anything. I want to get at the front panel switches here, which was also one of the areas on the set that when the set was dropped, this whole front was broken. So it may be just a bad switch or one that's jammed. So I'm just going to take this out here. I'm just going to release the little tabs. I don't know if you can see it there, but there's little plastic tabs that hold the switch assembly in, and pop the switches out. Something is kind of sticking in there. I might be on the right track already. You know, that assembly, that button assembly is kind of sticking. I might be on the right track. Okay, there's my switches. I think I may have a stuck switch. Unfortunately, I actually have to remove the tube from the bezel to be able to get at that thing to check it. So the tube is held in by 4 screws. So let's unscrew the tube. And I shouldn't have to remove my second anode on this thing. There's plenty of slack here. I've unplugged the shield for it, but I should be able to just remove these screws and lift the CRT out. And that way I can check those plastic buttons, because I have a feeling that what's happened is one of these plastic switches is jammed, and what's happening is it's holding one of these switches closed. And when any of these switches gets held in the closed position, none of the others will work. So I should be able to lift the tube out just like that. Put it aside. And now I can get at this button assembly. And it's fused to the cabinet. Interesting. See, I think I'm on the right track, because if I look at how these buttons are in here, it's like they're not centered properly. And yeah, that's a bit better. The TV video button's not centered. There, that's a bit better. Now my buttons are a little more centered. Still feel kind of sticky. The volume button especially. The volume down button feels kind of sticky. I think probably what's happening is the little plastic arms here that hold the buttons in place are starting to bend. Starting to get out of shape, or... Oh, there's the problem. You can see it right here. This is normally fused on with plastic. This one is broken. Aha! So what's happened is it's allowed this button assembly to come free, and it's allowed the buttons to get out of alignment. So I'm just going to have to heat something up to melt that plastic so I can put this piece, oh there, pop it back in, and hopefully be able to put the switch assembly back, put the picture tube back in, and this thing might work. But I'm just going to heat up my soldering iron and kind of fuse that over. That's how they put these in, is they just melt the tabs down. This one, as you can see, it's broken. You can see it broken free there, right? That's why I think that's what my problem is on this thing. So we'll just either glue or fuse that back together. I'm thinking fuse it back together with a soldering iron. Let me heat one up here and we'll fuse that together and try reassembling this thing and see if it turns on. And this tube was made at the holy grail of tube factories. This one came all the way from Japan. That was a neat thing about these small sets. Most of Sony's stuff in this era was made in Mexico. For the North American markets was made in Mexico. I think a lot of the stuff for the European markets may have been made over in Great Britain, where they had the big Sony factory over there in Wales, where they made a lot of Sony TVs for the European market in Wales. And that factory now is actually where the Raspberry Pi is made at the Sony factory. after they shut down the TV production. That and some real high-end cameras. All the real high-end Sony cine cameras apparently are still made over there. But I'm just waiting for my old iron to warm up so that I can, I'm not going to use my new iron on this, but I'm going to use my old iron to melt some plastic. So I'm just going to give it a few minutes to get up to temperature, and then we can try and get this cabinet fixed up and put it back together and hold it together with some more tape. Well, the iron's hot enough to burn my finger, so I guess it's now probably hot enough to try and fuse this back together. I'm just going to lay the faceplate down. I'm just going to heat up right over top of the existing fuse point and see whether I can stick it together. Success! We no longer have movement. I would say that's success. So now I can start to reassemble this thing in the reverse order that I took it apart. What I'm going to first do is I'm going to attach the switches back to the set. I'm going to unplug them from the main board here just so that they are free. I'm going to attach the switches to the front panel before I start assembling everything, just so that I don't add any stress to it while trying to get it back together. So the switches lock in underneath. There's a little tab down here that your switches go in, and then you just snap them in like that. Okay, now when they're locked in, the button should freely operate. Let's see if they, yep. Yeah, I think they freely operate now. I can hear them clicking. Next, we'll reattach the picture tube. So the tube just sets in place on its mount, and the shield goes around it. This is actually a very important part. This is the tube ground. You'll notice that there's a ground strap here, and that actually presses up against a carbon coating on the outside of the tube. So that dissipates any static charges that will be picked up on the outside of the glass. You've got your second anode voltage here, which goes to the second anode on the inside of the tube, which is a metal coating on the inside of the tube. But the thing is, you'll form a high voltage charge on the outside of the tube as well, just through the capacitor effect of the glass acting as a dielectric. So the outside coating will pick up an equally high charge to what's on the inside. And if that voltage is not, or that static electricity is not drained away, a couple things will happen. You could get a shock if you touch the outside of the tube for sure, but what generally happens is the voltage will get to the point where it will actually spark, it'll arc from the coating of the tube to either your yoke or to something else. And if it arcs to one of the circuit boards, for example, it can pop semis. If it arcs to the yoke, well, you can also still pop semis because the yoke's obviously connected down to your vertical and horizontal deflection circuits. So you want to keep that voltage drained away. This actually plugs into a ground pin that's right here on the tube socket. So you want to keep your tube grounded, otherwise, yeah, you'll have sparking inside, and you can have other components get damaged. Okay, now I'm ready to reassemble the tube into the chassis on this set. In this case, it just kind of sits in place like that, if I'm not mistaken. This one's kind of an oddball design, this set, and the tube actually, the chassis sits onto the tube, so it might be easier if I do it like this. there's a tab here that fits in the bottom, and this is part of where this cabinet is broken to. That's why it was held together with tape. But there's a couple tabs in here, and they just lock in on the bottom. Get these tabs down here. They're going to go into these slots like that, and that's how it sits in place. Now we can turn it upright, and we can proceed to reconnect our button board and our grounds and our CRT and the yoke. So we'll start by putting the yoke in, the yoke plug in down here. And secondly, we'll put in the button assembly, which is kind of hard to reach, but it is right here. Our all-important ground wire has to be connected, which connects back here. Now we can connect up the tube. Just got to still make sure that the cabinet is in properly. There we go. Okay, now the tube can be connected again. And finally, we have the power supply. We have our low voltage connector here that goes on the bottom. And these plugs only go on one way. And our main AC power. Slide the board into its board holder here on the side, and we'll apply power and see whether the TV turns on. Fingers crossed, power on. Ah, we have power. We have power, so that was what was wrong. It should say video here in a minute. There we go. We have power. Volume up, volume down, TV video. I don't know if I'll pick up anything. Shouldn't pick up anything here because there's no antenna on it, but if I were to bring my modulator signal, which is completely contained in coax, but my signals are pretty strong off my modulator here, so if I were just to take a piece of wire, for example, and just hang it on the end of my coax to the center pin, I bet you I will find that I probably can get a couple stations. Yeah. Let's hook the antenna up. I don't have an antenna on the TV right now, but if I just get the back cabinet here for it and hook the antenna up, turn it off while I do that. I don't want to stick my hands in where high voltage is. Okay, now we'll try it. No, the antenna on the TV is just the bar antenna, which is not extended, and what's transmitting that signal is it's just coming from my modulator. Right, I just have my coax line here, and I just have a jumper on there, so we're not really transmitting much power. I have my That's the blonder tongue that I just showed off, the channel 12 stereo modulator with the plus 60 dB output. Oh yes, hook that thing to an antenna, that thing's going to put out a signal for a few feet, okay? But I have another one that's on channel 9, which is not a plus 60 dB, and I have another one on channel 7, which is also, that's a 0 dB output, and I have another one that's down on channel 4, which is also a very low output. This is probably a minus 20 or minus 40, but you can see the difference in the level. Okay, that's a Radio Shack stereo modulator. Let me move up the band here. And this is an Olson technology. It's a professional one, but it's not a high output. It's just a standard output. And again, it probably is 0 dB. Another Olson technology. And there's the blonder tongue. And if I go up to UHF, I should have another one which is on channel 68. So it'll take a while to get there. This is a, might not even pick up a signal from it. Nope, it's gonna be too weak. Gonna be too weak. That was a Holland Electronics Agile Modulator consumer. But as you can see, that one really pounds out a good, clear, strong signal. That is incredible how strong that signal is. Okay, time to put this one back together and get this one back up on my test bench, as this is the little TV that I normally use when I'm working on VCRs and stuff, because it's an analog picture. And when dealing with analog video sources, especially interlaced sources, they look much better on an interlaced monitor. You guys probably saw, if you saw the VP1000 video where I had it playing on the plasma sitting beside me, and it didn't look so great. It was, especially because I was playing the high-speed time-lapse or ultra-lapse tape on it. But it was, the video was shot on a progressive scan, and it was converted down to 480 interlaced to be recorded onto that analog 3/4 inch tape. And now it's playing out on that analog 3/4 inch tape, and it was playing into my plasma monitor, which is going to convert it back to a progressive scan. So it started out as a progressive scan, was converted to interlace, and was then converted back to progressive scan. It didn't look that great, but when I played that same tape on my analog tube monitor, and I was going to show it to you on this one, but this one broke down. That's why I didn't show it on this one when I was working on that. I went to use this one, and this one was dead. So I had to use my plasma. But when I played that tape on my other 20-inch CRT set, it looked fine. So it was just the analog to digital conversion and then interlaced back to progressive on the plasma that made it look like crap. So when you're looking at an analog source off tape, an analog monitor always does a better job. Let me get this one back together. Something I never understood about Sony is why on this model they did this. Like, if you look at the cabinet, like the cabinet, it's like this is an afterthought. It's like, oops, we made the cabinet wrong. Let's have another little piece that you have to put in here to allow the back to line up. Kind of one of those little things like, okay, who thought this one through? And somebody out there with sharp eyes is probably going to know that there's no serial number on this unit. No, this unit was not stolen, but it was a write-off. It was an insurance claim. When the person that owned this set, and this is going back at least 20 odd years, maybe more, the person that owned the TV that dropped it claimed it on their insurance. And the insurance company required the shop to send them the serial number to show that the TV had been destroyed. So that is why there's no serial number on it. This TV was supposed to have gone in the garbage, but once the person made their claim, we removed the serial number label to send it to the insurance company to show that the unit had been disposed of. Then I was free to take it home and fix it. So If you're wondering why, no, I don't have any hot equipment here, but the reason that that one was done was because this TV had been a write-off for the previous owner. And in order for them to claim their damaged set, the shop I worked at had to give them an estimate, first of all, that it had been damaged. And the insurance company insisted on getting proof that the set was out of service, and that was it. So now I'm going to put it together this time, and I'm going to use some nice black tape as opposed to just using, I think I used packing tape the last time because I just put it together in a hurry. I'm going to use some nice black tape over here to hold this thing together, and this thing will go back up on my bench, and I'll be enjoying it for another 20 years. The only downside to this is, look at the stupid antenna connector. Hello? Like, nothing like putting a coaxial connector on there for an external antenna. But this TV was never intended to be hooked up to cable. If you notice the tuner, when I tuned the stations in here, it went 2 to 13, and then it went to UHF to scan the UHF band. It doesn't have a preset, it's just a scan tuner. And this does not have a cable compatible tuner. It will not pick up cable channels. It will only pick up the VHF and UHF channels. So as far as a TV use pretty much useless now, other than I use it as a monitor. Works great for that. We'll catch you in the next one. Bye for now.